Assalamualaikum warahmatullahi wabarakatuh. Today, our group will be present about Leg 1, which are design and analysis forecast disc brake system. Our group member consists of 5 people, which is Robert, me, ADIB, AIMAN, FAIZ and Hardy. Next, we move to the table of content. Our video will be included with the theory, procedure, structure analysis and experiment result, data, discussion and conclusion. The first part, theory. The disc brake features a metal rotor instead of a drum and use pad in the caliper to create friction against the rotating disc, slowing the wheel. Hydraulic pressure pushes the pistons, forcing the pads onto the disc. Uneven pathway may indicate a stuck piston. Always replace or refinish brake disc and pads in pairs, and avoid blowing brake dust which may contain harmful asbestos. Also, use a filtering mask for safety when doing service on brake pads.
The design begins by creating a new part in CATIA with stretching and extruding the rotor, and adding variation holes using the pocket and circular pattern tool. The caliper, housing and brake pads are created similarly, ensuring proper alignment with assembly constraint. Components are assembled in the assembly design workbench, refined with tools like hole and fillet, and assign material properties. The design is validated in the generative structural analysis workbench, then saved and exported in the required format for manufacturing.
Next, we go to the third part, which is data and finding. This table summarizes the key material properties of the rotor disc brake. First, young modulus. The young modulus is 2 × 10 power of 3 Nm², which indicates the stiffness of steel. Second, the Poisson ratio of 0.266 reflects the material's behavior under deformation. Third, density is 7,860 kg per meter cube, which help determine the weight and the inertia of the rotor. Fourth, thermal expansion, which is 1.17 × 10⁻⁻5 Kelvin. This is for analyzing temperature and induced deformations. Finally, the yield strength, which is 2.5 × 10⁸ Nm², which show the material strength limit before deformation.
The safety factor for the brake disc is 8.5 multiplied by 10 to the power of -4. This means that the brake disc can withstand a load of 8.5 multiplied by 10 to the power of -4 times the yield strength of the brake disc material before it deforms. The fact that the safety factor is significantly less than 1 is concerning. It indicates that the brake disc is not designed to handle the expected stress and could deform under load far below its yield strength. This low safety factor necessitates immediate attention to ensure the reliability and safety of the brake disc in operation. A number of factors can influence the safety factor of the brake disc, including the following. First, material of the braking disc. The choice of material directly affected the yield strength and consequently the safety factor. Design of the brake disc. Poor design may result in stress concentration or inadequate load distribution. Next, manufacturing process. Defected or inconsistencies in manufacturing can weaken the disc. And lastly, operating condition. High temperature, excessive braking pressure or other extreme conditions can reduce the effective safety factor. Consumer action. If experiencing brake jaded or fade, it is essential to have the brake system inspected by the qualified mechanic. They can diagnose the issue and recommend the necessary repairs.
It is crucial to select a brake disc with a safety factor appropriate for this intended application. For instance, a brake disc used in high-performance vehicle must be capable of withstanding greater stress and indicates that the brake disc is unsuitable for use without significant redesign or material improvement. To address this issue, these following steps are recommended. Redesign the brake disc, modify the design to improve load distribution and minimize stress concentration. Choose a higher strength material, select material with greater yield strength to improve the safety factor. Improve manufacturing process, ensure quality control to eliminate defects that may weaken the disc. Adjust spreading condition, reduce braking pressure or use brake pads designed to minimize stress on the disc. In summary, the current safety factor of 8.5 × 10⁻⁶ is far below acceptable limits, indicating a significant risk of deformation. Immediate correction action are required to enhance the reliability and safety of the brake disc.